This is it, everybody. This is the Barbie Bungie finale. At the end of this lesson, you get to attach a bunch of rubber bands to Barbie and drop her down the end stairwell and see if she survives. Are you ready? It's going to be great. So here we go. I have measured from the top of the railing. Kids in class, I'll show you how to where this is. You're going to drop her down the stairwell to the second floor below, and I measured that and did some calculations. That's 487 centimeters. That is our target height from our drop to the floor below. Okay. You are going to use your group's data right here, not mine, yours. Okay. And it'll be a little bit different. For the purposes of these notes, I'm going to use this data. Okay. This is a great summary. I would encourage you to try this entire thing by yourself rather than just listening to this video as you go. All right. Explanatory variable we've talked about many times. That's the rubber bands because it is the x-axis and it is also controlling the distance that she falls. Distance is the response. I have already put the data into my applet right here. Just be careful that you do as well, and then begin your analysis. There's my graph. You can copy and paste that into the applet. You can use this to get the correlation, 0.999. Look at that. And the equation right there. Y hat, or predicted Y, is 25.3333 plus 7.51190x. Bam, okay? So there it pretty much answers questions 4 and 5, okay? But it doesn't answer number 3. Number 3 is DOFs, if it says describe it. So let's see if you know which letters are which, okay? I've underlined a lot of it. So strength is here. This is the S. So it could be moderate, okay? This is the direction. It's positive because it's uphill. Linear, this is the form, okay? And outliers is the O for outliers. Suppose I don't need to write it twice. Okay, that's DOFs. Make sure you address all of those. Okay, there's a strong positive linear relationship between the number of rubber bands we put on Barbie and the distance she will travel, and there doesn't appear to be any outliers. This is an estimate. Try to do this before you look at the applet. You know, this doesn't have to be perfectly, but it should be pretty strong. I mean, look at that. That goes right through the middle. This is from the applet. Remember, it says what's the units? It's kind of a trick question. R has no units, sucker. All right. Um, it also says what happens if you graph the scatter plot with the distance traveled on the horizontal axis and the rubber bands on the vertical axis. Well, we've done this, and R would not change, but seeing is believing, so let's do this on the TI-84. Because maybe you're thinking, I can't use the applet on my test. You're right. I've already put all my data in the calculator. Ba-bam. Then I'm going to go stat, calculate. I'm going to do number 8 for kicks. Remember, you can do 4 or 8. You can store your equation in there by going alpha, trace, bam, and then calculate. And there it is. There's the R of 0.999. All right. If you want to answer that question of what happens if you switch the explanatory and the response variable, you can simply go back to stat, calculate. You can do number 8 again, and you can switch these first two. You can put L2 first, followed by L1, and hit calculate. And look at that. It's the same R value. Now, yes, A and B changed because I reflected my graph. My entire graph flipped. So my equation is different, but R is not changed because R is measuring relationship. All right. So that gets you through number 6. Okay. Let me go back and run the regression again. Number 8, but this time have it the way it should be, with rubber bands being first. I'll also get my store my equation, and then calculate it. That's what you need to grab for your number 7. What is the equation of the least squares regression line? The LSRL, okay? Transfer that over to your notes. Okay, and I've done that right here. Notice I've also done it with the little hat for predicted distance. Remember, that always means predicted. The least squares regression line is giving us predictions, okay, based on the number of rubber bands. Okay, on the calculator, by the way, if you want to see this, you just go to your stat plot menu, you turn it on, and then you should be able to hit zoom 9, and there it is. All right, let's do some interpreting slope and y-intercept. What is the slope? The slope is what's attached to your variable. So it's 7.51, but what the heck does it mean? I know we've talked about this before. Slope is the change in y over the change in x. That's a lousy triangle. My goodness gracious. Okay, and y, what's the y variable? This is the distance that she falls. And the x variable is the rubber bands. Okay? One of these days, I might get better handwriting. Maybe. Then you put the number to it. The slope is 7.51. Put it over 1, and this helps me to formulate that sentence that you see down here. If the number of rubber bands goes up by 1, the distance she travels will go up by 7.51. And I should be careful. I keep saying it will go up. It's not quite so strong. It is that I predict the distance will increase by 7.51 centimeters. Be careful to say that. The y-intercept is what happens when there are no rubber bands. It's what we predict to happen when there are 0 rubber bands. From the equation, it's this one because it's not attached to a variable. It's a constant, right? This is a constant, which will help. Later, you might see it referred to as a constant. Okay? So when there's no rubber bands, we predict the distance that she travels to be 25.3. Because when there's no rubber bands, you're not actually dropping her. So essentially, it is her height, Barbie's height. All right, number 10. I'm going to erase this and just start from scratch. Actually, the only way I know how right now, I'm going to do it the old school way and just draw over it in white and then come back and do it over. Okay. Oh, Figer. Okay. I've left some of the prompts. So first you start here with what was our predicted distance, and you're going to use the predicted line of regression. So that would be 25.33. Man, that Apple Pencil's not responding too well. Plus 7.51 times 4 rubber bands. You can do that on your calculator. You could also, on your calculator, if you want to take a little shortcut, you can also just go to your table, second table, and go down to 4. And there it is, 55.38. Okay? Which I've got right here. So we would predict that she would fall 55.38 centimeters. Okay? Then to get her residual, remember what we do is we take the actual y minus the predicted y. The actual y comes from the original table. What actually happened when they put 4 rubber bands on Barbie? they got 55. Okay, so that's what actually occurred. So that will go 55 minus what we predicted, which is what we just calculated. And you get a very small negative number, negative 0.38. You can use your calculators if you would like. Okay, so what does that mean? Make sure you interpret that. Don't just say, I found it. That means the actual distance that Barbie traveled was 0.38 centimeters less, because it's negative, less than we predicted. Another way to say this is, this just rings true for me. This dot is below the line, below the LSRL. It's underneath it. Another way to say that is, just look at it. Here's, well, I guess I don't have an accurate line. Do something like that, right? Roughly. Cheat it up so it fits my narrative. There we go. So it's the 4 rubber bands. That dot is slightly below the line. Okay. So in reality, she didn't fall as far as they thought and predicted she would. Sketch the residual plot for number 11. This is something you're going to do on the applet, not on the TI-84. This is not something I would have you do sketching this on a test, okay? So to get the residual plot, it's the second one down right there. You can either screenshot that and put that in, or just take your time and put those 8 dots as a sketch, okay? And I've already done that right here. Just things to note, again, remember the residual, the x-axis here is essentially a value of 0. All right, so number 12, what is the coefficient of determination? Well, it's on the applet. If I go back, it's down here, a little lower down. It's in the box next to the equation, 0.998. It's also on your TI-84s. If you run it again, stat calculate number 8, boop, 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 boop. It's right there, 0.998. Either way, that's how I got 99.8%. Just realize I took this and then multiplied it by 100 to get this. Okay? Multiply by 100. What does it mean again? This is telling you how much variability of the distance traveled can be accounted for by this line of best fit. This is really good. This is almost 100%. Almost 100% of the variability of the distance she travels is accounted for by this equation. So in other words, our equation is very, very good. If I was bungee jumping, I would feel pretty good about this. Okay? You might have a different number. Again, remember, this is all based on my data. You're going to have to do this for your own data. The standard deviation of the residuals, that is just S. This is not on your TI-84. This will always be given to you on a test, like in a table. So in your applet, it's right next to R squared, down here on the bottom. There it is, 0.989. Okay, and this is just a definition of what does that mean? The easiest way I can say it is it's the average distance these dots are from 0. It's the average residual. It is meaning the actual distance traveled is on average about 0.989 centimeters away from what we predicted it to be. So sometimes it'll be higher, sometimes it'll be lower, but typically on average, the distance she traveled is only off by 1 centimeter from what we predicted. This is about 1 centimeter. Okay, that's pretty darn good. I feel pretty confident if I was Barbie. Okay, so all in all, is this a good model? Is this a safe model? Overwhelmingly, yes. There's three main reasons. The residual plot doesn't show like a frowny face. It doesn't show a smiley face. Okay, it has no pattern really, no leftover pattern from the original scatter plot. R squared is very, 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 very close to 1 or 100%. And the standard deviation of the residuals is very low. It's only off by 1 centimeter. So when you're falling 487 centimeters, if your error is only about 1%, or sorry, not 1%, 1 centimeter, 1 out of 487 is not that large as a percentage. It's tiny. What is sorry, 1 divided by 487? 0.2%, folks. Um, that's the error, essentially. The average error as a percentage. Pretty good, okay? All right, drum roll. Finally, what are you going to do? Um, you are going to figure out how many rubber bands you need and then attach them and then drop Barbie. So to do this prediction, we're going to take our 487 centimeters. That is the distance we're dropping her. Put that here and set it equal to your equation and then solve it for x. This is a little bit wonky. Let me scooch this over. 487. Okay. On the calculator, what's that going to look like? All right. We're going to take our 487, subtract the y-intercept, and then divide by 7.51. Just a good old-fashioned solving. So I'm getting 61.47. So that means 61 point, what, 5 rubber bands? Oh man, the moment of truth. Be careful. Do we want to add or round up or round down? I would round down for safety, right? You add up to 62 and she might hit her head. So this is where you have to try to count out 61 rubber bands right now, tie them to her, and then drop her. I'd like you to record this slow-mo so we can see what happened to Barbie. Good luck, Barbie. I hope you survive. I'm so nervous.